Hi guys, welcome back to Chemistry 24/7. From this series, we are exploring to the solution of previous year competitive exam questions. In the way today, we are going to see this question. This is the question from CSIR 2014. According to this question, here you see this substrate when you use X reaction condition which produce sulfone product, then followed by when you use Y reaction conditions which produce this conjugate addition product. So here are the four options there. So we'll find out which one is suitable for this question. Let's see one by one. So this is the first option. The first option X reaction condition is the reaction of phenyl sulfonic acid in the presence of BF3 etherate, as well as Y reaction condition is ethyl acrylate in the presence of BF3 etherate. So let's see one by one. So first, initially this substrate having hydroxy group, two lone pair of electrons, which readily one of the lone pair of electron readily attacks the BF3 etherate. That means coordinate with BF3 etherate, since BF3 etherate here acts as a Lewis acid, which produce this corresponding structure. Here now you see this oxygen has two lone pair of electron, one of the lone pair of electron shifted here, then followed by kick off this unit, which produce corresponding oxonium ion intermediate. The next step is the reaction with phenyl sulfonic acid. In principle, phenyl sulfonic acid can act as a impetant nucleophile. That means that oxygen or sulfur can act as a nucleophile. In our case, sulfur acts as a nucleophile. Here you see how this happened. This oxygen lone pair of electron goes here, then followed by the sulfur lone pair of electron attacks here, then followed by this electron shifted towards to the oxygen atom, then followed by loss of H plus ion, which produce corresponding sulfone. So based on this, so the first reaction, first condition of X is correct. So next we should look the reaction condition of Y. So the reaction condition of Y is the reaction with ethyl acrylate in the presence of BF3 etherate. But our final product is conjugate addition product. So therefore, we need some strong base in order to produce some nucleophile. Okay, this compound having acidic proton this side, so definitely we need some strong base. When you use BF3 etherate, this reaction doesn't happen. Therefore, according to this, the Y reaction condition is not suitable for this transformation. So let's move on. Second option. The second option, X reaction condition, is reaction with thiophenol and para-toluene sulfonic acid. And the second condition is the reaction of metachloroperbenzoic acid. The Y reaction condition just like similar to our previous case. So we can easily eliminate the Y reaction condition. Okay, anyway, we should see what happened when you use the X reaction condition. So initially, this substrate, the same substrate, when you use para-toluene sulfonic acid, here para-toluene sulfonic acid, this one, which act as a Bronsted acid, that means that donate the H plus ion, therefore which readily protonate this hydroxy group, which produce this corresponding protonated form. So just like our in previous case, this oxygen lone pair of electron just pushes here, then followed by kick off the water molecule, which produce corresponding oxonium ion intermediate. So the next step is the reaction with thiophenol. So here thiophenol sulfur acts as a nucleophile. Here you see has two lone pair of electron that readily attacks this center, then followed by shift this electron towards to this oxygen atom, which produce corresponding derivative. So when you treat with metachloroperbenzoic acid, which produce corresponding sulfone compound. Let's see magnetically how this happened. So here you see this derivative when you treat with metachloroperbenzoic acid, which produce sulfone derivative. This one is metachloroperbenzoic acid. This one acts as a oxidizing agent, particularly this oxygen-oxygen bond is weak, so that can be easily cleavable under this reaction condition. So now you take this substrate. So this sulfur has two lone pair of electron that readily attacks this oxygen atom, then followed by this oxygen-oxygen bond breakdown. These electrons are shifted here, then followed by these electrons readily takes the H plus ion. This electron moves towards to the oxygen, which produce this corresponding sulfoxide derivative along with corresponding carboxylic acid as a byproduct. So we can write like this. So now you see this sulfur atom again having one lone pair of electrons therefore which readily react with just like our previous equation which produce sulfone compound. So based on this, the first reaction condition is suitable for the conversion of sulfone compound. However, the second reaction condition we discussed in our first option, so the Y reaction condition is not suitable for the conversion of this corresponding conjugate addition product. So let's move on our third reaction condition, third option. The third option, they provided phenyl sulfonic acid and BF3 etherate. And Y reaction condition is LDA and ethyl acrylate. So here you see the first reaction condition. So when you use phenyl sulfonic acid, this one is just like as our para-toluene sulfonic acid. So this one acts as a Bronsted acid, and BF3 etherate here acts as a Lewis acid. Therefore, when you use these acids, so which readily remove this hydroxy group, which produce this corresponding oxonium ion intermediate. However, here there is no nucleophile, therefore this reaction here stopped itself. Therefore, the first X reaction condition is not suitable for the conversion of corresponding sulfone. So let's move on the Y reaction condition. Therefore, the Y reaction condition is LDA. So LDA we already discussed in our channel. So LDA is one of the non-nucleophilic sterically hindered strong base which can readily take the proton from less hindered site having acidic protons. So here our compound having acidic proton this center. Therefore, when you use LDA, which readily produce this corresponding carbanion intermediate. So this carbanion intermediate quickly react with ethyl acrylate. So here you see this electron attacks here, then followed by this electron shifted here. This electron move towards to the oxygen atom, which produce this corresponding intermediate. So when you do acid workup, so which readily produce this corresponding conjugate addition product. So based on this, the first reaction condition, that means X is not suitable for this, but Y is suitable for the conversion of sulfonic acid to this corresponding conjugate addition product. So let's move on our final option. So just now we discussed this all reaction condition, either X or Y. So therefore, based on our previous discussions, so the X reaction condition is highly suitable for the conversion of this corresponding sulfone, and similarly, the Y reaction condition is highly suitable for the conversion of corresponding conjugate addition product. So therefore, based on our discussion, we can easily omit the first three options. The correct option is number 4 for this question.